Construct a fourth-order Taylor polynomial at x equals 0 for the function, this one. All right, so Taylor polynomial, if you remember, this is my equation right here for a Taylor polynomial. So what we need to do is we need to find the derivatives and the non-derivatives, because this one is going to be 0 for the first one, which means the first thing I need to find is f of 0. And f of 0 is going to be e to the 2 times 0, which is going to be 1. And then I need to find the first derivative. So the first derivative at 0. Well, the derivative is going to be 2 e to the 2x. And then we're going to evaluate that at x equals 0. So this equals 2. And then we're going to do the next one. And that's going to be 4 e to the 2x, evaluated at x equals 0, which ends up being 4. The third derivative at 0 is going to be, let's see, the derivative e to the 2x, and then the derivative of the inside is 2, so that becomes 8. And then evaluated at x equals 0 is going to be 8. And then one more, since we have to take the fourth order, which is going to be, looking at the pattern, it's going to be 16. All right, now we're going to use this equation right here. And we're going to start at 0. So I want my f function, so my 0 derivative, so my function at 0, which is 1. And so we're going to do 1. And then it's going to be divided by 0 factorial. Well, 0 factorial is 1. So I'm not going to write anything. And then you get x to the 0, which is nothing. So my first term is going to be 1. Now, we are going to do this first term. So the first term is going to be my first derivative at 0, which is going to be 2 divided by 1 factorial, x to the 1, plus 4 over 2 factorial, x squared, plus my third derivative, which is going to be 8, over 3 factorial, x cubed, plus 16 over 4 factorial, x to the 4th. Now to simplify it, we need to do 1 plus 2x plus, now 2 factorial is 2 because that's 2 times 1, so it's going to be 4 over 2, which is 2, x squared, plus now 3 factorial is going to be 3 times 2, which is going to be 6, and that's going to become 4/3 x cubed, plus now 16 over 4 factorial is 4 times 3 times 2, which is 6 times 4, which is going to be 24. So this is going to be 16 over 24. And if I reduce that, that's going to become 2/3. So we end up getting 2/3 x to the 4th. Now, this right here is what they're asking for. So that's my answer. Now, if I wanted to find the actual Taylor polynomial, I'm going to make this video a little longer and find the actual Taylor polynomial, even though they're not asking for it. To find the Taylor polynomial, the easiest way to do that is to actually find the nth term. So if you look at the pattern here, this is going to be 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4. So this Taylor polynomial is going to look like this. Well, it's going to be 2 to the n over n factorial x to the n. So if I write it as a Taylor polynomial and actually make it go on forever, it's going to be the summation from n equals 0 to infinity of 2 to the n over n factorial multiplied by x to the n. So that is my actual Taylor polynomial.